everyone. Hello students. Today's topic is integers. In standard 6th also we have learned something about integers. There we had discussed means in standard 6th what do we mean by integers, how we have to add them, how we have to subtract them. These two or more operations also we had discussed. Here in this standard, in standard 7 in mathematics, and in this particular chapter 1 integers, we will talk about two more operations of integers. One is multiplication, other is division. Means we will learn how we have to multiply any two or more than two integers and how we have to divide integers. And related problems also will be the part of the chapter. So first of all, in your exercise first A, here a recap is given which we had discussed in standard 6th. Also we are coming to that first of all. After that we will proceed for the further operations of integers as multiplication and division. So first of all, before coming to the integers, first of all we will talk about what do we mean by integers. And before coming what do we mean by integers, let us talk about collection of some other numbers which we know from the early classes. See students, first of all let me introduce a name natural number. What do we mean by it? As you are familiar with the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on. You are familiar with these numbers from the earlier classes, LKG, UKG, standard 1st, 2nd and onwards. From there you know these are the numbers only. Although most of the time whenever we count whatever objects or human beings, we use these numbers. For example, suppose we want to count how many students are in your standard, then we will say there is one child, there are two students, there are three students, four students or whatever, or there is no student. So that's why we call them counting numbers also. But in the higher classes, all these type of numbers if we collect together, that collection we represent with this symbol. So these numbers 1, 2, 3, 4, 5, 6 and so on means the counting numbers. So collection of these counting numbers we represent by the set n, and here stands for natural. So these are known as natural numbers. Now if we talk about what do we mean by natural numbers, so easily we can say counting numbers 1, 2, 3, 4, 5, 6 and so on are known as a natural numbers. So if I ask you, is 1 a natural number? Yeah, 1 is a natural number. Is 2 a natural number? Yeah, 2 is a natural number. Is 100 a natural number? Yeah, 100 is a natural number. Is 1000 a natural number? Yeah, 1000 is a natural number. Is 0 a natural number? No, 0 is not a natural number. Why? Because 0 does not come in this collection. So that's why 0 is not a natural number. Similarly, -1, -2, are these natural numbers? No, they are not natural numbers. As well, they also are not coming in this collection. So that's why they are not. So looking at a number, we easily can identify that whether the number is natural or no. Now let us come to one more collection. You are familiar with that also. In the earlier standard we had discussed. Here, see, if we collect all the natural numbers 1, 2, 3, 4 and so on. In this collection, no doubt this is collection of natural numbers only. If we include one more member here as 0. So in this collection one more member as 0 we have included. Now it has become new collection. And including 0, this collection of natural numbers is known as set of whole numbers or collection of whole numbers. We denote it by W. We denote it by W. So W is what? W is the set of all the whole numbers. So whole numbers means 0, 1, 2, 3, 4, 5, 6 and so on. These numbers are known as the whole numbers. Just only the difference between the set of natural numbers or collection of natural numbers and collection of whole numbers is of 0. Here is 0, here is not 0. So from here we can talk about an idea saying 1 is in this collection. Is it a whole number? So no doubt it is a whole number because it is in this collection. So whatever number is in this collection, that always will be said as whole number. So if I ask you, is 6 a whole number? Yeah, 6 after 4, 5, 6 will come no doubt in this collection. So that's why 6 is a whole number. So from here we can say every natural number is a whole number. Because why I am saying every natural number? Whatever natural number you will take from here or from this collection, 1 or 2 or 3 or 4 or whatever, that number will be here also. That will be member of this collection also. So that's why every natural number is a whole number. You can keep in mind every natural number is a whole number. But if I ask you, is every whole number is a natural number? No. Let's take a whole number 4. We are taking from here because this is collection of whole numbers 4. So 4 is here. Is it natural number? So to check it is natural number or not, let us come to this collection. Is 4 exists here? Yeah, 4 exists here. So that's why 4 is natural number also. So 1 is here, 1 is also there. So 1 is whole number, so 1 is natural number. 2 is here, so 2 is whole number. 2 is also there, so 2 is a natural number. Similarly, other than 0, every member of this collection of whole numbers is also a member of that collection of natural numbers. So every whole number other than 0 is also a natural number. But 0 is here, but 0 is not there. So that's why 0 is not a member of that collection. So 0 is whole number, but it does not come in this collection. So that's why it is not a natural number. Only on the basis of this information, we have to keep in mind every whole number is not a natural number. So that the next information which you have to keep in mind, that every whole number is not a natural number. Now we know how we have to add any two integers, natural numbers, how we have to multiply them, how we have to subtract them. Means the 4 basic operations: addition, multiplication, subtraction, division of natural numbers we know. Similarly for whole numbers also we are familiar with these 4 operations. Here we will talk about one more collection of numbers, that is, if we represent these whole numbers on a number line. So we will represent like this. On this line there are infinite points. So let us choose this point and this point. Let me denote here 0. Suppose here is 0. And now we have to represent here 1. So here is 1. For example, between 0 and 1 we have chosen, suppose, 2 centimeter distance. So now if you are representing 2 on the number line, so you have to keep in mind as difference between 0 and 1 is 1 and this difference is 1, so that's why for one difference we have taken distance between these two numbers as 2 centimeter. Similarly, when you are writing 2, then difference between 1 and 2 is also 1, so this length also must be 2 centimeter. So at the distance of 2 centimeter you can represent the numbers 3, 5, 6, 7 and so on. So here we know that all these numbers 1, 2, 3, 4, 5, 6, 7 and so on are to the right side of 0 on the number line. Are to the right side of the 0 on the number line. If we change only the direction, these are to the right side of the 0. Now if we represent them to the left side of 0, with the same idea we have to represent them. Here is 1, here is 2, here is 3, here is 4, here is 5 and so on. In this way we can proceed till that side and similar to that side. But the difference between that and this is only the difference of direction. So that's why this is the direction is opposite to that. So to represent this direction, we use here a symbol that we call minus sign. It is minus 1, it is minus 2, it is minus 3, it is minus 4, it is minus 5. So these numbers are to the left side of 0. Including these numbers means minus 1, minus 2, minus 3, minus 4, minus 5. With this collection of numbers 0, 1, 2, 3, 4, 5, 6, 7 is known as a collection of integers. So collection of integers let us know by which English alphabet we denote the collection of integers. Here, this collection of integers we denote by I or Z. 0, 1, 2, 3 and so on. Minus 1, minus 2, minus 3 and so on. So 0, 1, 2, 3, this side minus 1, minus 2, minus 3 and so on. All these numbers which we have put here in this bracket or this collection of numbers which we are denoting by I or Z is known as a collection of integers. Means these numbers are integers. So if I write here 2 and suppose we want to check is 2 an integer? Yeah, 2 is coming in this collection, so that's why 2 is an integer. Is 3 an integer? Let us check this collection. Yeah, 3 is coming here, so that's why 3 is also an integer. Is 0 an integer? Yeah, 0 is also an integer because 0 is coming here in this collection. Similarly, is minus 1 an integer? Yeah, minus 1 is also as well, minus 2, minus 3 and so on. All these are integers. So from here, 2 more informations are there. What are they? Say, if I ask you, is 1 an integer? Which is a natural number also? Yeah. Say, 1 is coming in the collection of natural numbers, so no doubt 1 is natural number. But 1 is also present here, so that's why 1 is an integer also. 2 is coming in the collection of natural numbers, so that's why 2 is here, so 2 is a natural number, no doubt, but 2 is also here, so that's why 2 is an integer. In this way, if we proceed for every natural number which we will find here also, so we can say every natural number is a whole number. Every natural number is a whole number. Now same thing, let us think of whole numbers also. As you know, this is collection of whole numbers 0, 1, 2, 3 and so on. So 0 is here in this collection, no doubt 0 is a whole number. Is 0 also here? Yeah. 0 is also here. So we can say 0 is an integer. Is 1 here? So 1 is also a whole number. But 1 also presents here. So that's why it is also an integer. So we can say every whole number is in this collection. So that's why every whole number is an integer. Every whole number is an integer. We have to keep in mind. Every whole number is an integer. If we think of their converse, that is not true. Converse means what? Is every integer also a natural number? Answer is no. Suppose we want to check 0. 0 is here, but it is not in collection of natural numbers. So that's why it is not a natural number, but it is an integer. Similarly, -1, -2, -3 and so on. All these are members of this collection, means all these are integers, but they are not in collection of natural numbers. So that's why all these are not in natural numbers. On the basis of this, we can say that every integer is not a natural number. Same thing for whole numbers. Every integer is not a whole number. For example, -2 is an integer because it is in this collection, but it is not member of collection of whole numbers. So that's why it is not a whole number. So about integers, about whole numbers and natural numbers we have discussed, and how we have to represent their collections, means by which English alphabets we have to represent their collection, that also we have discussed here. Now we will talk about positive numbers and negative numbers. For today, we'll talk about only that much. What do we mean by positive integers? What do we mean by negative integers? That we will discuss next time. That's all. Thank you.